Ladies and gentlemen, boys and girls, welcome back to another video. Here we have the exam, so let's figure out how we do this. Critical numbers for f are only points such that f prime is 0. We know that this is false because it's also where f prime is undefined. Function e to the x has no critical numbers. This is true because e to the x, the derivative is e to the x, right? So we say, so how do we find critical points? We say f of x equals e to the x. This means that f prime of x equals e to the x. We want, for critical points, this to equal 0, but how would you solve for this? We'd say that x equals ln of 0. And of course, ln of 0 is undefined. This does not exist. This is in like negative infinity. And we know that e can never be 0, right? So if you look at the graph of e to the x, it looks something like this. So, you know, you're never going to have it being 0. Okay. Let's see what our next question is. What do we have here? Consider the following picture of the derivative f prime. Based on the graph, which of the following is true about the function? So a derivative, we're looking for critical points, right? When do we have a critical point of f? This is when the derivative is equal to 0, right? So we just look here, we get our zeros, we say negative 0.7746, 0, and positive. So it's going to be this one here. What is the following limit equal to? So when we see something like this, where what is, if you plug in your limit, what do we get? It's going to be 0 over 0, right? So how do you figure out what the limit is? Well, then that's when you take the derivative, right? So here we're going to say the sine of x, the limit of sine of x over x is going to be the same thing as the limit of, what's the derivative of sine? Cosine. What's the derivative of x? 1. This is going to be the limit as x approaches 0 of cosine, and what is that? We know that cosine of 0 is 1. Okay. It's very important with this L'Hopital's rule that you don't actually do the derivative of this. So you're not doing like low d high minus high d low over low squared. You're just doing like derivative divided by derivative, right? Compute the following integral. You must show work for partial credit. So we've got 8 sine x minus x cubed plus e to the x minus 4. Okay. So we've got this guy here. How do we do this? Well, we're just going to anti-differentiate each thing separately. So the antiderivative of sine, right? You think about sine goes to, when you're doing derivatives, sine, cosine, negative cosine, back to sine. So we know that the antiderivative of positive sine will be negative cosine. So it's going to be negative 8 cosine of x. 8 here, sorry. X to the negative 3. So we have x to the negative 3. We're going to add 1 power and then divide. So we're going to go up to negative 2. So this will be x to the negative 2, and we divide by negative 2. But we have a negative out front already, so it's just going to be positive plus x to the negative 2 over 2. You could have also written 1 over 2x squared. These are the same thing. Alrighty. Derivative of e to the x is just e to the x, which means that its antiderivative is also just e to the x. And then we have negative 4. You just go, that's a constant, so negative 4x. Plus c. If you're ever doing these antiderivatives, you can always check your work. So take the derivatives. What is the derivative of negative 8 cosine x? That's going to be 8 sine x. This is going to be minus x to the negative 3rd plus e to the x minus 4 plus 0. So this here would be our answer. Alrighty. We want to build a box. Let's just copy and paste this so we don't have to keep looking at it. Okay. We want to build a box whose base length is 6 times the base width. So what we're going to have base length is 6 times the base width. It will enclose 20 cubic inches, which means that length, width, height equals 20, because that's going to be our volume, right? And then the cost of materials is 3 inch for the sides and 15 for the top. Or $3 per inch squared on the sides and $15 per inch squared on the top. So our constraint, this is our constraint. And our objective function will be what? So if you look at your box here, you're going to have this top part is going to be length times width. So you're going to have $15 for those. And it's going to be length width. Plus, now you're going to have this face is going to be 3. Length height. And then plus 3 width height. Right? And this is going to be the total money that you're spending to build the box. Now notice that we've got this face, but we've also got this bottom face. We've got this side, but also this side, and also this side. So, because it's, it's a cube, so it's got 6 faces, not just these. So we're going to have 2 times this. And this is actually the exact same problem as the one from the practice, like the practice exam. All right, let's see. Clearly state, then define the dimensions of the box. Okay, we want to minimize our cost now. Yeah, so this is kind of a weird way to... so our cost here is our objective. So how do we minimize this guy? Well, we have to take a derivative, right? But we have a bunch of different stuff going on here, so we got to solve. So here we solve these. This one first is going to give us that. So length is 6 width. So using these, we're going to say that width times length times height equals 20. And this means now that h is going to be 20 over 6w squared. Okay, so now we plug everything in. So this is going to equal 30 length times width plus 6 length times height. Length times height. Plus 6 width times height. Right? Now we solve. We're going to say, yeah, let's say that the 6w should be in here. Okay, so now we can solve. We can go ahead and say that this guy here is going to be... Oh, wait, sorry, forgive me. I got to check for a second. So we've solved in terms of this. Okay, perfect. Now what we can do is we have 180 w squared plus... this 6 cancels with this one on the bottom, and one of the w's cancels, so we'll be left with 120 on the top and w on the bottom. And we'll be left on the same over here. We're going to have w divided by, or sorry. 20 divided by w, correct? Does this check out? You guys all agree with me here? I think, right? So 120 divided by, 20 divided by w. Okay, perfect. So now this guy is going to equal 180 w squared plus 140 over w. We take our derivative here now. So O prime of w is going to be 360w. This is w to the negative 1, so we're going to have negative 140 over w squared. And now all you have to do, we say that we want this to be 0. Of course, if w were to be 0, then we would have 0 width. That doesn't make any sense, so we can go ahead and just multiply up our w squared. This is going to say 360 w cubed minus 140 is going to be, what is 0 times w squared? Well, it's just 0, right? This guy's still 0. And so now w is going to be the cube root of 140 divided by 360. You could divide that out by 20, and that would give you, 7 over 18. This is the cube root of 7 over 18. This would be your final answer here. Alrighty. That's going to be that problem. Okay. Now let's do our final problem. So here we're saying that we've got this function. We need to find where the global max and min could occur. So we know this will occur at critical points or endpoints. So first, let's just solve for our critical points. So critical points. F prime is going to be what of x? What is f prime of x? Well, 9/4 x to the 4th. You multiply down the 4. So this is just going to be 9x cubed. Derivative of 9 is, or 9x is just 9. Derivative of 2 is 0. And we want this guy equal to 0, which means that 9x cubed, we want to equal -9. We divide by 9 and we solve. X is going to be, x cubed is -1, x is -1, right? And then endpoints is just going to be -2 and 0. So now we have -2, -1, and 0 are the only points that we could have a global max or min. All right. If you have any questions, feel free to email me. I hope that you all have a wonderful day. And I am just going to finish up. I graded all of them except for this problem. So I'm going to grade that now. By the time you see this video, the grades should be up. See you guys.